Today, Dan Clark Audio is launching an all-new flagship headphone, the Dan Clark Audio Stealth. And the Stealth is definitely Dan Clark Audio's best headphone to date, and one they're attacking the higher end of the high-end with. That they'd eventually move up market didn't surprise me. For many years now, Dan Clark has built a successful business of designing and manufacturing moderately priced high-end headphones that usually punch well above what you're paying for them. I think, though, that many Dan Clark Audio fans, myself included, wanted to see their engineers reach even higher, unencumbered by the need to build to a moderate price point, to have the free engineering reign and whatever time needed to claim their place at what this community considers summit-fi levels of performance. For years now at Dan Clark Audio, they've been doing extensive research and development on some very innovative technologies with an eye toward crafting their first cost-no-object non-electrostatic flagship headphone, which it turns out is the new Stealth. And the Dan Clark Audio Stealth is a closed-back assault on the higher end of the high end. There are reasons why the majority of the most revered flagship over-ear headphones, the one many in our community consider the best of the best, there are reasons why most of these are open-back designs. When you put a headphone driver in an enclosure, covering its backside as you do with a closed-back design, all sorts of challenges arise. Remember that drivers radiate sound from their backsides too. With an open-back design, the sound coming from the driver's backside is much less consequential, free to dissipate to escape into the ether. Close it off, though, and there are reflections and standing waves to contend with, and that is a fantastic engineering challenge, or really a host of challenges that are presented when trying to make a good or great-sounding closed-back headphone. A tremendous amount of consideration, then, has to be given to damping and absorption within the cup with a closed-back headphone to deal with those reflections and standing waves that would otherwise reach the user's ears. Every maker of excellent closed-back headphones knows this, some going to great lengths to address these very things. Dan Clark Audio has made some exceptional closed-back headphones. Dan started the company with a closed-back headphone, so this damping and absorption is certainly something they've done increasingly well over the years. For the Stealth, though, Dan Clark Audio, or DC Audio, is employing something that almost seems counterintuitive. As Dan said to me the other day, conventional wisdom tries to avoid putting things between the transducer and the ear. But the team at DC Audio also wanted to address standing waves and reflections that happen in the space between the ear and the driver, and doing so involved doing the counterintuitive. Dan Clark actually shared their invention with the legendary headphone engineer Axel Grell, one of the key figures behind some of Sennheiser's legendary headphones like the HD600 and 650, the HD800 and HD800S, my all-time favorite, the Sennheiser HE1, and many others. Knowing that Dan had shown it to Axel, I asked Axel what he thought. He said the invention solves some acoustical problems with just one part, and that it's a big step ahead. Coming from Axel Grell, that's really saying something. Now, rather than try to explain what DC Audio has done, I'll let Dan Clark do that for me. Dan came to visit us at HeadFi HQ a little while ago, and we had a chance to talk to him about the Dan Clark Audio Stealth and something called AMTS. So Dan, thanks for coming out to HeadFi HQ.
It's always a pleasure to leave San Diego for sunny Detroit.
Thanks for doing that. So, this is your new flagship, which is what you're here to talk about.
Yes.
It's the Stealth.
Yes.
And it is planar-magnetic, correct?
Yes.
All right. And so I want to dive right into the guts of this because you've been sharing this with me in bits and pieces over a fairly long period of time.
Yeah, you've probably been getting measured response plots on this project for about a year and a half.
Yeah. Check this out. Check this out. I'll sometimes wake up because our time zones are a little different, and then I'll find a measurement from you in chat. But and then also a couple of these cool parts. But you've been, we've been talking measurements for a long time, but I didn't get a chance to hear this till a couple of days ago.
Yes.
So it's very impressive. It's your flagship. It's a planar-magnetic, if we didn't clear that up already.
Yes.
Can you tell us more about the guts of it? This
Sure.
is all new, first of all?
Sure.
Okay.
This project actually started as the replacement to, or an update to Ether C Flow when we began Ether 2. And we thought we'd be able to relatively easily repurpose the Ether 2 driver into an Ether C Flow type chassis to deliver a closed headphone, and it was not possible. The Ether 2 driver just didn't react right to the dynamics of having a cup behind it. So we started from scratch and we developed an entirely new driver from the tensioning of the diaphragm all the way through the mechanical design where it's just a couple millimeters thick as an assembly. To make our thinnest driver to date and also our best driver to date. It's quite large. It's about 30% larger than an Ether 2 driver. And it also uses a ton of magnets, 15 magnets per channel. So there are 30 magnets in each headphone. And we did that because the thinner driver architecture allowed us to basically take a lot of the mechanical structures out of the way that we used to have to put the flow technology to get around smoothly. And now in this design, that's really just been taken out of the equation.
Gotcha. So this is an all-new driver, obviously, then.
Yes.
And you said that it's there's 15 magnets.
Yes.
Now, when you said it's a couple of millimeters thick, so you said it's 30% larger. Obviously, we're talking about radiating area.
Yes.
And then it's a couple of millimeters thick. Does that include the magnets?
Yes.
All right. Very cool. So I haven't seen that yet.
Yep.
I want to open that thing up, and I want you to show it to me. But so that's very neat. And then as far as so there is nothing that's in common with the specific driver assembly with the, say, for example, the Aeon
That's
or
correct.
the Ether.
This is an entirely new system.
Okay. Now, the magnets you were telling me about the magnets and where they are relative to the driver, the ear.
Yeah, the magnets are on the outside. That's something that when we first began with the Ether line, the magnets were on the inside. And at that time, our testing showed that that worked better. As we got better at testing and also our driver designs and flow technology improved, it turned out to be better to move the magnets to the outside. And in this design, that was the case too. Flipping it around did not do well. Moving the motor to the outside was definitely advantageous. And we put the driver in a enclosure that's very heavily damped, so we've taken great care that there are no reflections going on within the cup.
Because it's closed?
Because it's closed.
All right.
We wanted to make sure we didn't have standing back waves and group delay issues from a ton of energy reflecting around in the system. So it's extremely well-controlled energy within the cup. And then we did something really new. So we talked a lot about the driver, and that's a key part of the design. But another key part of the design is this subsystem we call the AMTS, or Acoustic Metatuning System. And the idea is that there's a new concept in physics called metamaterials, which are materials that are not found in nature, which can be used for specific properties. And in this instance, what we're doing is we're creating a programmable array of dual function waveguides. So when the sound comes out of the driver, it goes through a screen and then enters this waveguide, which orients the wave up toward the ear. And we found that subjectively that changes a little bit about your perception of where you hear the sound stage and moves it from being up here when you listen to more like this. And to me, that seems more natural and immersive. So that's an immediate benefit of that. But a hidden benefit is that when we configure this correctly, these become waveguides and quarter wave or Helmholtz resonators. And the beauty of a quarter wave or a Helmholtz resonator is that we can use those to remove standing waves and resonances that occur within the ear cup cavity that your ear lives in. Think of it as the room that your speakers are in. You know, everybody is used to rooms having resonant modes like standing waves and bass that make rooms sound wrong and reflections off walls that mess with the imaging. All that's going on in the headphone ear cup, except that it's at very high frequencies. Now, it turns out that this quarter wave resonator can control those frequencies. And by making a ramp like this, we have an array of resonators. At the highest here, they're about 8 kilohertz. We can fold the resonator within the part to reach even lower frequencies. And then by the time you get down here, they're 20 kilohertz. So you can see that as we come in this axis, we can then turn on or terminate some of these waveguides to turn them into resonators to address frequencies anywhere from 5 kilohertz up to ultrasonic. And if we have a particularly strong peak, by going down this axis, we can terminate multiple resonators to achieve higher damping at a set frequency. So we can now control both a broad range of frequencies and create specific and deeper notches at individual frequencies. So this gives us the ability to program the high frequency response of the actual final system.
Yeah, because you can't, obviously you're holding it with the front side out, but the back side you can see it looks like a random pattern of some of them are closed off. But that's obviously not random. That's
correct.
The programming you're talking about.
That's correct.
Okay.
It's based on both measured responses and also listening tests where we listen for peaks and dips, and then we use the metamaterials to get rid of them.
Now, you're mentioning it's smoother, but it's still detailed. You showed me measurements fairly early on, and then now some more recent ones. We haven't had a chance to complete the measurements here at HeadFi HQ yet. on our fixture, but on your measurements, you showed a very smooth response that was unsmoothed, right? So it was an unsmoothed response.
Yes.
What I mean is you didn't smooth the curve, and yet it was a very smooth curve up top. Is that kind of what we're talking about here? Is that part of the result of, what's that called again, the AMTS?
AMTS.
Yeah, okay, AMTS.
Yes, that's right. And if you put the headphone on and you listen to a sweep or a noise function, you'll hear it's smoother, and it just is. There may be other headphones that are out there that are that smooth up high without the benefit of this. I can't say for sure because I haven't measured every headphone that's out there. But certainly in the work that we've done, this was a fairly substantial transformation of the upper range. And, it really just makes me want to dive into my collection and kind of listen to everything I can find that had drums or strings and say, oh, that's why I love that track.
Now you can see it in the headphone.
Yes.
Under the grill cloth.
Yes.
But I can't say that I've ever seen anything exactly like that in any other headphone. So to the best of your recollection, I'm not aware of any headphone that uses something like that.
I'm not either. I believe this is a totally novel innovation. In fact, we think this is one of the better inventions we've had, and we're patenting this internationally. This will be our first global patent.
Really?
Because it's really interesting technology, and we have done some experiments where I've been able to apply this to other headphones that were already built. And I can retroactively apply this to some headphones and improve their performance. So there's lots of potential for things to do this. I mean, there's nothing that says we couldn't, for example, take a really popular headphone and make an insert for a popular headphone to modulate its response. It's a neat piece of technology.
This is one of the things that I enjoy about our chats because you're always showing me something new. You kind of gave me a hint that what I'm about to mention is something we can't really talk in detail about, and I'm not likely to be able to show pictures of. You touched on it briefly, but it's kind of funny to me because I know how important it is to the process, the tensioning. Like you mentioned that, and you developed techniques and machinery for the purpose of tensioning. And just to clarify, you're not going to let me show pictures of that, right? That's very proprietary.
Yes.
Okay, but let me just say that if you could see the machinery, it looks like it would do a whole host of things.
But it doesn't. It does one thing
really well. It does one thing
well.
really well to tension the drivers.
Yes.
So that they're consistent.
Yes.
So I wanted to mention that because I'd love that you innovate, because that you created in-house completely. But there's another thing that you didn't create in-house completely that I also want to mention, because I don't think we've mentioned on video in a conversation between us, but I think I've mentioned it on preview videos. And I think this is important stuff. For a company your size, another thing that impresses me is your use of the Klippel, the driver matching system. And the, Tyle Hertzens from Interfidelity, his last video, I think it was the last video he made for Interfidelity, wasn't it? A visit to you?
Yeah, his last one when he came by our shop.
Yeah, it was like right after one of our Can Jam SoCals, and he went to go see you. And then he retired, but he
yes, that was our fault. We did that.
He drove him into retirement. But he came out, and all kidding aside, he did a fantastic video, a tour of your place, which I know has changed since. But one thing that he covered was the driver matching room.
Yes.
And in that room is a Klippel driver matching system. It's a multi-parameter driver matching system. I've seen it at other companies, usually much bigger companies. I don't know. Maybe there are smaller companies like yours that use it, but I don't know of any offhand. And I think that is fantastic that you do that, because coming off the jig that I can't show, that very carefully match tensions the drivers, you probably already have a good pair by most standards, right, that you could just then use. But you're further testing it to get what are already essentially a whole bunch of drivers that could be matched pairs to match even tighter.
That's right. And we actually even match drivers in the $500 Aeon RT as matched drivers. It's done through the entire line.
So it's not just the Stealth, okay.
That's right. It's not just Stealth. And what we've done, the higher end headphones, we match through a broader range of the spectrum with an even tighter tolerance. Okay. So whereas like the Aeon RTs might be matched to a half a dB from within their target matching range, the Stealth will be matched to maybe a quarter dB.
Gotcha. And what we're talking about, just to be clear, is the drivers, because when you mount them in the Klippel, they're mounted independent of any of the rest of the headphone assembly onto the measurement system directly.
Though we took that one step further, actually. With Stealth, we're not just matching the drivers, but with Stealth, we're matching the drivers in the enclosure.
Oh.
So that way, the finished system is being matched without the ear pads.
Without the ear pads. Because the ear pads or where you get a little more variation, obviously.
Ear pads have higher tolerances because it's a sewn fabric,
Right.
you know, and so you have plus or minus a millimeter tolerance there, and also pads compress slightly differently because the foam may not be exactly identical between pieces, and within the pad, as the pad compresses or crushes, the cross section of how the fabric will collapse will vary from headphone to headphone. So ear pads introduce error.
Sure.
There's nothing that's technologically possible to do for that, though we have filed another patent on that.
Right.
Because we do have a possible solution, but we haven't fabricated that yet.
Well, yeah, no, so yeah, I just wanted to bring up the extent that you go to get your drivers matched, which I found very impressive. I thought that was really cool. That was Tyle's last video, not just showing Clipple, but the whole tour. Anyway, I thought I'd mention that too. Now, obviously, I'm most excited about all these things we're talking about that have to do with the sound. But we have to talk about, at least briefly, the design, because this is an all-new design.
Yes.
Physically as well.
Yes.
So please touch on that, because it is also the best looking headphone you make. I would say probably one of the best looking closed headphones I've seen.
Cool.
So let's talk
Thanks.
about the chassis.
Well, I think the first thing is we cued the design from Aeon because it's just so ergonomic and comfortable, and people really have reacted very well to the shape. In fact, we actually got a design patent on the Aeon shape. But we did modify some other things. So I'll talk about what we kept first. We kept the teardrop shape because that really pulls the headphone back out of your line of sight, so you can have a full-size headphone that's not intruding into your peripheral vision. And it also gives it the ability to drop down your jawline here, where most people are fairly flat, and it gives us a better universal seal than a different geometry. The other thing we did was we preserved the folding gimbal from the Aeon 2. So this is a super friendly travel size, as you can see from the little case that it comes with. And finally, we made a major change in the headband. Two things. The first is a cosmetic change, which is opening up the headband wires to create more of an open and flying design rather than two parallel lines. But the real thing is that instead of having an adjustable headband with ratchets or sliders, as we've used in the past, this is on an elastic that allows the headband to fit anyone without adjustment. And you simply put the headphone on, pull it down a little below where you're going to let it go, and then push it up to get it to the spot you want, and that's it. And it's a universal fitment. So we tried to combine a ton of comfort and good ergonomics and then make it really beautiful. Part of the design here was also to reduce the weight while having it stay very strong, because with 15 magnets per driver, the drivers weigh more. And one of our hallmarks has always been making headphones that are lighter than you'd expect.
Sure.
This one weighs in at 415 grams. It's a little heavier than the Ether C Flow, but not a lot. And that's despite the fact that there are twice as many magnets in the motor.
I would not have, I wouldn't have guessed it was heavier than the Ether C Flow, so.
Yeah, it carries its weight really nicely,
Yeah.
because the headband has also got a quilting inside it to give it a little bit of padding, and it's a wider design to spread the weight around. And then the ear pads have a very generous amount of surface area, so that they spread the pressure very evenly, and it's spread very evenly across the top of your head. And as a result, you have a headphone that is very comfortable, and you don't have any pressure points or hot spots. And again, you can wear it for hours.
Yeah, I find it very comfortable. Again, I've only used it for a couple of days, but what I always worry about, like when you told me you were using the self-adjusting the self-adjusting headband, I always worry about the elastic, because I've had some that I put on where it starts to push, lift the headphone off my head.
It either goes doing or
right. No, you got that one right, because it's neither sinking nor coming up on my head. So at least for me, so far it's been very, very comfortable. So I love the design. I'm glad you used the gimbal still, that you continue to use that. And this is still nitinol, right?
Yes.
All right, so I don't have to worry too much about deforming that. So no, I love the design too. I'm really excited about this. When is it going to be available?
It will be available the day we announce.
The day, like this, when we put this
Like
up?
today, when this video goes
Okay.
live. This is the first time we've had a product that's available on announcement, which is something that we're really proud of. We've always wanted to do that, and this is the first time we have the scale and resources to actually do that.
Well, so hopefully we don't run late making the video. But anyways, all right. Well, I do thank you so much.
If you do run late making the videos, I guarantee we'll be shipping by the time you release
then you'll really
it.
be shipping by then. No, this is great. I'm very excited about it, because we've been talking about it for a while. Again, we've been sharing. Well, you've been sharing measurements and other information about it, but now it's real. So anyway, thank you so much for taking the time to come out from San Diego to Detroit to talk about this, and it's nice to have you out again. It's been a while.
Thank you. Appreciate it. A pleasure as always.
The AMTS technology Dan Clark Audio developed for their Stealth is patent pending, I believe, and it's so cool, so trick, and something I don't think we've seen the last of with the Stealth, given the broad range of parameters they can program into it. With AMTS, again, with a single very complex piece, DC Audio integrates waveguides, diffusion control, quarter wave, and Helmholtz resonators into one compact structure, able to control resonances and shape frequency response from 3 kHz up to the ultrasonic. As Axel Grell said to me, AMTS is a big step ahead. Since Dan's visit, I've spent a lot of time with the Stealth, and it is simply superb. It is every bit a top-class flagship non-electrostatic headphone, yes, even on the higher end of the high-end, open back or closed back. But when it comes to closed backs, the Stealth enters Grail territory. I'm one of those people who often requires a headphone of closed back design for isolation from the world around me and to avoid bothersome leakage when I'm around others. And for people like me, Grail territory means a closed back headphone that sounds and feels like an open back one. A closed back that sounds and feels like an open back is one of those asymptotic goals, one you can keep having the distance to but never reach. With the Stealth, DC Audio has halved that distance more times than any other closed back headphone I've heard. If I'm listening to the Stealth in a quiet room, I can completely forget it's a closed back. In a louder room, when there's more ambient noise, the muffling of that noise through the cups brings me back to remembering it's closed. But some of the key open-like characteristics are a benefit in any environment. For example, its tonal balance is very neutral. I frequently talk about how neutrality is a range more than a single thing, that there's a range of neutrality. If the Stealth has bass lift, it's minor at most, but super extended. The Stealth's midband is, to my ears, straight down the middle, colorless in the very best way, but still real and meaty. And the Stealth's treble is probably the most resolving of any closed back I've heard of any type, but smooth. This tonal balance is important, as this kind of tonal linearity is one you rarely get with a closed back, and none I've heard exceeds the Stealth in this way. In terms of the wideness and airiness of its soundstage, maybe its only currently available competition in that specific respect that I've heard is Sennheiser's HD820, which also images very wide for a closed back. At least off the top of my head, that's the only competition I can think of for openness and airiness in a closed back. But the Stealth has a couple of key advantages versus the HD820. It's definitely more neutral than the HD820, its bass less emphasized, more linear, and more resolving. The Stealth is, to my ears, also more resolving throughout the audio band, with cleaner lower mids and, again, more linear throughout than the HD820. I think the HD820 is one of the most misunderstood, most underappreciated of high-end closed-back headphones on the market, but as closed-backs go, I'll say with high confidence that the Stealth will simply be the clear preference between the two to most in this community, especially those who favor neutrality. For the last 2 or 3 years, the Focal Stellia has been my favorite closed-back headphone of any type. The Stellia has been my closed-back reference since its release. And there are times, because I'm the type of audiophile who likes his bass stronger than neutral much of the time, that I still prefer its tonal balance to the Stealth's. But there's no question whatsoever that the Stealth is the more neutral of the two, especially through the bass, and no doubt that it's the more open-sounding of the two. This is a closed-back battle royale that'll no doubt be fought for some time on my head and over my ears. One of my recent closed-back favorites is the Audeze LCD2 Closed. The Audeze LCD2 Closed is such a fantastic closed-back option if you have to stay under $1,000, and tonally, I'd call it a solid center strike in the range of neutrality. But on balance, I have to say the Stealth is even more neutral, more linear, and its treble is more refined and smooth, and it's definitely the more open-back sounding of the two. For under $1,000, the Audeze LCD2 Closed is just so good, but if you want a neutral closed back that sounds more like an open back, and you have the means, I highly recommend the Dan Clark Audio Stealth. Anyway, let's get to measurements, including some measurement comparisons. The following measurements were made using the Brüel & Kjær 5128, which is the most human-like ear simulator standard, and what we've transitioned to as our primary headphone measurement fixture. The 5128 is the first hearing simulator that simulates adult human hearing across the full audio range from 20 Hz to 20 kHz. This is the Dan Clark Audio Stealth's frequency response, which I think is superb. For a planar-magnetic headphone, even unsmoothed, which I'll post in the accompanying forum thread, the Stealth has a very smooth response, with much less of the bumpy irregularity frequently seen in planar-magnetic headphone frequency response measurements. This is the Stealth's total harmonic distortion measurement, or THD. The Stealth has extremely low THD, well behaved throughout the measured band. Here's the Stealth's THD at just over 111 decibels, driven with 3 volts from the benchmark HPA4 headphone amp. THD remains below 0.5% and is actually mostly 0.1% to 0.2% through most of the measured band. Again, that's at just over 111 decibels, so I have no hesitation whatsoever EQing the Stealth with abandon. This is the Stealth's frequency response compared to the Focal Stellia. This is the Stealth's frequency response compared to the Audeze LCD2 closed. For the sake of direct comparisons to some of the most well-known headphones in our community, here's the Stealth compared to the Sennheiser HD800S. And compared to the Sennheiser HD650. The Dan Clark Audio Stealth should be available right around the time you're watching this, and it'll be priced at $3,999. Thanks again to Dan Clark for flying out from sunny San Diego to Detroit to visit us at HeadFi HQ, and thanks to you all for watching this episode of HeadFi TV. We'll see you next time and on the forums at headfi.org.